call it as a de facto standard approach in identifying and maintaining hazards on process planned in most developed countries. So there is no doubt that the technique deserves much credit for avoiding loss of life and as well as preventing costly accidents worldwide. So because of the very comprehensive and painstaking keyword approach, a HAZOP study requires a significant and dedicated human resource for the duration of the study, which can be weeks or months based on how big is your organization and where or how much complex is the facility where you will be doing your HAZOP study or your HAZOP study. So HAZOP is based on the principle that several experts with different backgrounds who will interact and identify more problems when working together than when working separately and combining their results. Although the HAZOP study was developed to supplement experience-based practices, when a new design or a technology is involved, its use will expand to almost all phases of a plant's life. So the gate word HAZOP is the most well-known for the HAZOPs. However, several specializations of this basic method are being developed. Now let's quick look onto the Q&A session. Hello all, good evening. So we will generally we'll end up this particular session in 1.5 hours to 2 hours is what we will do all these things. Okay. So I'll straight away go to the other subjects and all, and then we will go one by one on the questions. So again, the HAZOP concept, the main concept or the main idea behind HAZOP is to review the planned in a series of meetings during which a multidisciplinary team, as I said on the previous slide, and who all are those team members, we will have a look onto our upcoming slides. Particularly, we call it as a brainstorming session within the plan design and following a particular structure provided by the gate words as well as based on the team leader's experience. The primary advantage of this particular brainstorming is that it stimulates creativity and generate ideas. So this creativity results from the interaction of the team and their diverse backgrounds. So process requires that all team members must see that members hesitate to suggest any ideas. So the HAZOP team actually mainly focuses on specific points of the design, usually called as study notes, one at a time. So at each of these study notes, deviations in the process parameters are examined using the gate words. Now what are those gate words, keywords? We will definitely look on our upcoming slides. The gate words are used to ensure that the design is explored in every conceivable way. Thereby, the team must identify a fairly large number of deviations, each of which must then be considered so that their potential causes and consequences can be identified. The success or failure of a hazard operability studies or otherwise HAZOP can be on several factors. So let's look on to what are those factors on which a particular HAZOP study is based on. So the first one is the completeness and accuracy of the documentations that you have. It could be drawings or it could be any other data that we can collect for the study. So the first process, so the success and failure, as I said, it depends on certain parameters. So what are those parameters? So the first one is the completeness and the accuracy of the document. So what is that? So the foundation of, I would say the foundation of an effective HAZOP is a reliable documentation, we can say. So this includes detailed and up-to-date drawings such as P&IDs. P&ID means a process and instrumentation diagrams, and any other data that are relevant to the system which is under study. So these documents must accurately represent the current state of the system to ensure that the HAZOP team can identify potential hazards and operability issues. So inaccurate or incomplete documentation can lead to oversight of risk and can result in ineffective risk mitigation strategies. So the accurate documents is the first part for a successful HAZOP study. Then comes the team who are being involved in this particular HAZOP study. The team itself is very important. The team expertise. So the expertise of the HAZOP team is paramount. It's very important. So members should possess a deep understanding of the system's design, operation, then as well as any potential failure modes. So the team typically comprises of individuals from various backgrounds or various technical backgrounds, which can include process engineering, instrumentation, then safety, as well as operations. So these members' collective technical skills and insights contribute to the thorough identification of hazards and the evaluation of risk, severity, and its frequency. So an inexperienced team might sometimes miss a certain kind of data, but critical risk or fail to predict the cascading effects of certain failures. So the team is very, very important. Selection of the right team. Then comes the ability of the team to use a particular approach, or otherwise we can call it as in a simple line, the creativity and analytical thinking of this particular team that we are selecting, or those who are involved in this particular HAZOP exercise. So we have to understand that HAZOP is as much a creative exercise as it is an analytical one. The methodology is designed to prompt the team to think beyond standard operating conditions. So we have to think in a very wider scale. What can go wrong? That's why I said it as it is a brainstorming session where we argue with each other. What is the reason why that particular pump can fail? What will happen if the pump fails? That kind of thinking. So that's why we call it as they should be able to think beyond a normal or a standard operating condition and should So the team's ability to imagine possible what will be the cause of it and crucial. This particular creative process often reveals unexpected vulnerabilities in the system that might not be evident through a pure technical analysis. And then comes the fourth part, which is, I would say, the team's ability to concentrate on the more serious hazards which are identified, or we can collectively call as a simple word, we can call it as the focus on significant hazards. We did a brainstorming session, we identified a couple of hazards and also how well we are focusing on it. So it is very important that we have to consider all potential hazards. The HAZOP team must also prioritize the identification and discussion of the most serious risk, those with the potential to cause significant harm to people, environment, and within the business itself, or the process plant, or whatever, wherever we are doing this particular study. So this focus ensures that the most critical controls and safeguards are in place to manage these risks effectively. So, preventing the processes from becoming bogged down and less critical issues. So these four factors decide the success and failure of a particular HAZOP study. So once again, the first part of a successful HAZOP study, noted down, which is the accuracy of the documentation, the completeness of that particular documentation. Then comes the major part is the team's expertise, who all are being involved on it. Then comes the creativity as well as a critical thinking or an analytical thinking, a creative thinking of these involved team members. Their involvement itself is very crucial. Rather than sitting over there, you do, I'm not interested, taking phone calls or attending to other additional phone calls and all, will not help you to have a good thinking. And then finally, focusing on significant hazards. So these all factors will decide a particular HAZOP study's success or whether it is a failure. Now let's look on to some of the HAZOP's key features. So some of the key features of a HAZOP study. Now, this particular HAZOP study is a creative process that actually proceeds from systematically using a series of gatewords to identify any potential deviations from the design intent and employing these to stimulate the team members to envisage how the deviation might occur and what might be the consequences. So, usually HAZOP study is carried out under the guidance of a trained and experienced study leader. We call them as a HAZOP chairman, who has to ensure a comprehensive coverage of the system under study using logical and analytical thinking, which we have discussed on the previous slide. So the study leader is preferably assisted by a recorder who records pertinent data associated with the identified risk and any other operational disturbances for risk analysis, evaluation, as well as any kind of treatment. Now, the HAZOP study, we have to understand that the HAZOP study relies on specialists from various disciplines with appropriate skills as well as experiences who will display a good intuition as well as a good judgment skills. So that is very, very important. Now comes the atmosphere. See, the HAZOP study has to be carried out in a particular atmosphere which is of critical thinking in a frank and open atmosphere. There is no space and there is no place where you can hide something. It is a very serious exercise and you have to be open in discussing the topics over there. So a HAZOP study produces minutes, or it is usually done through a particular software to record any kind of deviations, their causes, consequences, and the recommended actions that for the deviations that we have identified. Then it is along marked up with the drawings, documents, or any other representations of the system that can indicate the associated minute number, and where possible, we'll add all those recommended actions. So, the development of risk treatment actions for identified risk or operability problems is not a primary objective of the HAZOP examination, but recommendations, whatever we say, the team should say the recommendations that should be made where appropriate and recorded for considerations by those responsible for the system design, so that they can incorporate these changes in order to make the plant safe. So the initial HAZOP study might be done in a progressive fashion so that the design changes can be incorporated, but the complete HAZOP study has to correlate to the final design intent. Now let's look on to the next part, which is risk identification or otherwise different life cycle stages. What are the different life cycle stages on which we can do it? The first one, risk identification studies during different system life cycle stages. Is there any important see what is the difference between design review HAZOP? Design review and all is a part of this particular HAZOP itself. So that's something, some of the questions, but all these questions are important questions we will answer at the end. I can see that there are a lot of questions coming in. All those questions we will try to answer at the end. So then come now, we will discuss on the risk identification studies during different system life cycle. The first thing is the concept stage. One of the questions answer is right over here. Somebody has asked the same question. The question is right here. The risk identification is an essential process in the system life cycle that can vary in approach and detail at different stages. The first stage, let's say concept stage. So what is this concept stage? So during the concept stage, or we can call it as the early stage, the starting stage. So the primary design concept and the major system components has to be determined, and detailed designs and documentations required for a comprehensive hazard and operability studies may not be yet available. So despite this, it is crucial to recognize the major risk to inform the design process proactively and to lay a groundwork for more detailed future HAZOP studies we can see. So as the intricate details needed for a HAZOP study are absent on this concept stage, we may recommend any alternate basic methods, such as for example, that are more appropriate to a conceptual phase, because we don't have that much of data. We are just in the starting stage. So a detailed HAZOP study sometimes might not be possible at that time. So these methods, some other secondary methods may help you to pinpoint any potential risk that should be addressed as the system design evolves. Then comes the development stage. See, the development stage here is recognized as a cost-effective point for conducting a HAZOP study. The main reason is because the detailed system design is incomplete and the methods of operation have been established. In this particular stage, the development stage, it allows for a thorough examination of the system under the conditions where it will operate, and it will ensure that all aspects of the design and its operational context are evaluated for any kind of potential risk. So as the design progresses towards finalization, it may undergo several changes or alterations. That's how the system, when we design, when we actually put this into real factor, there can be many changes that needs to be adapted based on the goal. So each change introduced to the design must be assessed for its risk implications. Therefore, we can say an established process is essential for evaluating the impact of any design modification post HAZOP analysis. So this ensures that the initial risk assessment remains valid or is updated to reflect the current state of the system design. Maintaining this particular process throughout the life of the system is very important. By doing that, what we will gain? It will ensure that the system's safety, reliability, and operability are continuously monitored and managed. That's why we say that this particular process should be maintained throughout the life of the system. Now comes the next part, which is called the realization stage, the actual stage where it will be coming up. Let me see any important questions. So the realization stage. What is this? What is called the realization stage? The realization stage is a critical phase in the life cycle of a system where the theoretical designs and plans are transformed into what you call a physical and operational realities, where it is actually put into life form. So during this particular stage, risk identification takes on a more practical and immediate significance as the system is actually prepared for commissioning and initial operation. So this is a particular period known to have or known to present significant risk if it is not managed correctly, because here is where this particular stage is where we bring things into life mode. So before the system is commissioned, a dedicated risk assessment study should be conducted, and this study is essential as it allows the identification and mitigation of risk that are unique to the system's startup phase. We have system startup risk assessments, system shutdown risk assessments, etc., some of them. So proper operating sequences and instructions are crucial at its juncture to ensure safety and functionality. Now in this stage, the realization stage often includes final adjustments to the system's design. Any substantial change in design or intent from the original specification would necessitate a repeat of the risk assessment study to address new risk that these changes sometimes may introduce. So in this particular stage, additional data such as detailed commissioning procedures, then operating instructions should be available. And this information is very important for conducting a comprehensive risk assessment. And finally, a thorough review of all actions and recommendations conducted to confirm the completion. Now comes the utilization stage, what is called the utilization stage. So during the utilization stage of a system's life cycle, the HAZOP study focuses on the system's actual operational performance, examining the effectiveness of the risk mitigations in place. So it is essential to observe the system user interactions very closely to identify the risk stemming from both routine and unforeseen usage patterns. Sometimes we will not be able to, to predict everything that can happen. Sometimes there will be some unforeseen patterns or usage patterns that could be noticed. So the system must be evaluated under stress conditions to determine its resilience to any kind of unusual events or operational failures which can happen. So any new risk associated with regular wear and tear, then maintenance activities, human factors very important. It is not necessary that I should think in the same way that you people can think. There will be some physical, psychological issues that can affect a particular person's operating capacity or how he operates in that particular plant. So continuous monitoring mechanisms are crucial for detecting new risk as they emerge, and feedbacks from various users who are involved in the actual processes, incident reports, these all must be integrated into the risk management process. So this particular approach ensures a dynamic and responsive risk management strategy that adapts to changes and maintains the system's safety throughout its operational intent. So that means throughout its operational life cycle. Then comes the enhancement stage, the last of the two stages. This particular enhancement stage, we can say, of a life cycle is characterized by the introduction of upgrades or modification to the existing system performance. During the running of the plant, we may add many new things. A good example is Piper Alpha. I hope most of you must have heard, who are in this particular field must have heard about the Piper Alpha incident, which has happened in the North Sea for the company called Occidental. The platform was designed for something different, and later on during the life cycle, of that particular platform, they decided to add in more and more changes, which they have done without doing a proper HAZOP study or a risk analysis study, we can say. They introduced many additional points onto it, there are many additional structures onto it, like gas production plant, etc., storage of these gases, introduction of new machines, everything, which was not at all planned at the design stage. This all happened in the enhancement stage when they found out additional resources, natural resources. They decided to redesign the platform, adding more data, more and more critical operations into the plant without proper thinking, without proper study, and that has resulted in world's one of the biggest disasters in the oil and gas industry. So, in this enhancement stage, a HAZOP study, this particular stage actually necessitates a meticulous review of these enhancements to identify and assess any new risk that may arise as a result of change of the system. Initially, we make something for some particular purpose, and when you are adding some additional systems onto it, this can change the entire operational method. The hazards associated with can be completely changed. A very good simple example is a modification of our car, which is absolutely banned in many countries. You cannot actually modify a car without the permission of its manufacturer or without the permission of the regulatory body which is applicable in that particular region. So when people do these kind of modifications, it is bringing on additional hazards and it has to be analyzed in the enhanced. That is called this particular enhancement stage. So in addition to that, the integration of sometimes new components or a new feature with the existing systems has to be thoroughly evaluated to prevent the emergence of unforeseen hazards that can compromise the system's integrity or safety. Every system is being designed with a particular intent and that has to be maintained. And if you have to bring in some changes, introduction of new machines or anything, feel free to do it. But proper risk assessments has to be done, particularly like HAZOP studies and all. Then these operational procedures, the training that has been received for the staff, all must be revisited. And it has to be regularly updated to reflect the enhanced system. What kind of changes have you brought in? Have you changed your SOPs, standard operating procedures? Have you trained your staff on the new changes that has been done? How well you have done, what are the frequency on which you give them the training. So by doing this, ensuring that all users of that particular plant are adequately informed and they are well prepared to interact with the new features safely. So this process of updating is not only about maintaining safety but also about optimizing the system's operation in light of the enhancements. So lastly, the enhancement stage should be viewed as an opportunity for continuous improvement, and the insights that you gain from both the operational experiences and the enhancement processes should be fed back into the risk assessment practices, and that's a good culture. And finally, the retirement stage, or we can call it as the phase-out stage, or where you completely demolish or stop it or whatever it is. Now, this particular retirement stage marks the end of a system's operational life cycle, and it introduces a unique set of risks, sometimes that must be managed through a systematic HAZOP study. This particular stage involves a thorough identification and assessment of various risks associated with the decommissioning process, which can include a safe shutdown of the existing system. Not only safe shutdown, it can include a dismantling of its components, then safe and secure disposal of any residual materials or any hazardous materials that can impact the environment or the people, those who live by, etc. So, special attention has to be given to the environmental impact of the retirement, ensuring that all activities comply with environmental standards and regulation. And any potential contamination or any kind of hazardous waste that could be generated while you are doing this particular decommissioning processes has to be carefully identified, managed, and any risk associated with it has to be properly handled. So the next part we will see is the HAZOP study team, which is a very important one. Who all can be in a HAZOP study team? Let's look on to that. Who all can be a HAZOP team? A HAZOP team is a very good question. That's why you all are here. You all are here to learn more about HAZOP. And how I can be a member of this study, or otherwise known as a HAZOP, is once again a comprehensive risk assessment process that will involve the collaboration of a dedicated team of experts. So in this case of a very large project or a complex system, it can be sometimes very necessary to involve multiple teams to conduct the HAZOP analysis effectively. So these teams should work in parallel to systematically identify potential hazards, then assess the operability of the system, and also to evaluate the associated risk. So by having a very good team, we can actually distribute the workload among several team members, and thereby organization can ensure a thorough examination of the entire project. So different people with a different competency can be involved for it. So this is the team members that you see on the screen. A HAZOP chair, a HAZOP scribe should be there, a person who takes notes, the project or site process engineers, then project or site electrical controls instrumentation engineers, then senior operational representatives, a process safety engineer should be there, maintenance team should be there, or sometimes even external team members also can be there. Then operations representative can be there. Then these all people can be a part of HAZOP. So the important is that the person providing the information should be a part of that particular operations itself, so that he can give you some valid information. So these people who will be involved in it would be those people who actually operate the plant on a daily basis, and they will be able to provide invaluable insight into how the plant works in practice. So an experienced operations representative is essential to the successful operation of a particular HAZOP. Now let's look onto the size of that particular team. Now, as I said earlier, a HAZOP team's size should be determined primarily based on the complexity of the plant which is under consideration. How big is that? How much hazards are involved and how much is the job that we will have to do. So generally there should be 4 members per study team, but more than 10 members can be detrimental to the study. And there is also one more drawback on it. If the particular HAZOP team is overpopulated, then continuity can be lost and side discussions can take place. Side discussions means 2 or 3 people sit together and they have their own discussions, sometimes which may not be contributed on the final hazard report. Some responsibilities of the chair, or we call it as the HAZOP chairman. The HAZOP chairman actually plays a pivotal role in the HAZOP study process, who will serve as the leader and facilitator of the particular team. His primary responsibility is to guide the team through the study systematically, ensuring that the HAZOP methodology is followed rigorously. So he initiates the discussions on each node and guides the team in examining potential deviations from the intended design and its associated hazards. So overall, the HAZOPs chairs the leadership. He should have a technical knowledge and he should be able to facilitate proactive discussions, and is a very key member to the success of the study. Then comes the next person, which is a scribe. The scribe actually, what is he? He plays a very a critical role in ensuring the smooth operations as well as the documentation of the HAZOP study. So the scribe is actually responsible for recording all discussions, comments, and findings during the HAZOP sessions. He creates and maintains the HAZOP worksheet, ensuring it is accurate, and it should also reflect the outcome of the HAZOP study. This particular person's attention to detail, his organizational skills, ability to accurately capture the crucial when we say about a HAZOP scribe. Now comes the safety engineer's job. Why is a safety engineer role very important for all of us? So a process safety engineer is the responsible person for preparing, facilitating, then leading, documenting, verifying, and as well as communicating the HAZOP analysis to every other team members. He or she provides the necessary information and documentation on the process design and operation, and also applies aid words to the entire study process deviations. And moreover, he or she also presents and explains the HAZOP outcomes to other stakeholders and management, and to ensure that the HAZOP recommendations are aligned with the safety and business goals. So this is also a very, very important person who should contribute to this particular HAZOP study very effectively. Now, before I pass on to the next team member, let me see some questions. I can see some people have raised. Can I have a copy of all the learning matters? It should be given to you, but there is a course also associated which we will discuss on the last part on the part. Okay, so the data will be shared. Some points will be definitely shared to all of these at the end of the presentation itself. Now, so for introducing, now this is about a small glimpse about the HAZOP, and now we go on to the main part. So for the next part of our HAZOP webinar, please allow me to introduce Ms. Nancy Grace, a distinguished chemical engineering graduate with a master's degree in industrial safety engineering, and she is having a heavy experience of 10 years, and she has got extensive experience in manufacturing domain of high energetic materials, and she is certified member of IOSH, but she has also attained her commitment to upholding and advocating. And let me tell you that she also possesses a substantial expertise in conducting various comprehensive HAZOP studies. And I'm not taking too long onto it. Let me introduce and let me welcome Nancy Grace to continue this particular session. And over to you, Nancy. Thank you.
Thank you very much, sir. Am I audible to everyone?
Yes, you can carry on, Nancy.
Yeah, okay. So, sir has been briefed about how to conduct the HAZOP team and what is HAZOP, why it is essential. So, the main thing, why HAZOP team requires all these people. A plant requires all the people, like they require the civil engineers, electrical engineers, process engineers, equipment, civil, piping, instrumentation and control. Because in a major process plant industry, what are all the activities we do? Okay, we do process system designing. Okay, mechanical equipment will handle. Technical safety people are required pertaining to what are the hazards with the mechanical items, human errors, hazards, substances. Okay, so meanwhile, while sir is discussing, I have answered some of the questions that raised by the students. Okay, hope that is given you some brief introduction. So now I'll be dealing with HAZOP terminologies. Okay, so the safety team, the process HAZOP team is a must.
Sorry to interrupt, Nancy. You can share your screen if you want. I have given you the permission for it. You can share it.
Okay, sir.
placed over
So
there.
element
And
4,
then you can continue.
HAZOP terminologies. First, this is called PFD. PFD is process flow diagram, where this shows all the means like equipments, pipelines, everything in a brief manner. Okay, so if you see this, you can identify what is the product you are handling, what is the cooling tower. So where is the fractionating column, what is the input, what are the inputs, that means what are the upstreams and what are the downstreams also you will be knowing. So what is the HAZOP, how the HAZOP is different from other hazard identification techniques is mainly in HAZOP, in design phase, after you get your design parameters, that means my fractionator have to work at 50 degrees temperature only. Its pressure has to be at 2 megapascals only. That is the designed parameters. That means your intentions. That means to get a product, you require some of the important operating parameters like pressure, flow, level, temperatures. So all this, if it deviates, what are the hazards that we are going to identify in the HAZOP study? HAZOP means hazard and operability study. The deviations in the operating parameters will cause some of the hazards. Okay, so how we have to do, how to select, which element we have to select, from where we have to proceed, how to proceed, all this we will see in this further slides. So this is PFD. As sir has mentioned, what are the documents required for the HAZOP methodology? First thing, you require process description. What is your process? Then you require the process flow diagrams, utility connections. You require P and IDs. This is called P and ID. That means process and instrumentation. Suppose you have a fractionator here. So to control the flow, what is the input to control the flow? What you have kept? What instrumentation you have kept? Okay. If it is malfunctioning, what is the failure? Okay. So this is P and ID diagram. So this is called process instrumentation diagram. And if you see this, you require a specialized skill to identify the elements. Suppose this is a valve. This is a means like pressure control valve. Okay. This is an pneumatically operated valve. This is a manual valve. To identify the nodes, you identify the equipments, you require some of the knowledge about the instrumentation diagrams. Okay. If this is the line, this is the means like this is supply line, and if you see this line is going to the plant. So if you select, if this is the whole system. Okay, you cannot do for the whole system. Means like HAZOP you cannot do for the whole system. You have to select some of the nodes. Suppose here in the whole system, if you are selecting only the diaphragm pump and the tank in it, okay, then you have to study. So in this line, what are all the pressure, temperature, okay, what is my flow rate? If simple, if the pump is delivering high flow rate, if the pump is delivering low flow rate, what are my consequences? That you have to study. What could be the causes? That means this is the diaphragm pump. Maybe this is operated by pneumatic supply. So my supply pressure is less. So whom I have to contact? So HAZOP is a proactive study. That means you're not doing it after the accident. You're doing it before you are commissioning. As sir said, you are doing this in a design phase. Once some of the people have asked, what is PHA? What is the difference between HAZOP? PHA is done at pre-design phase. That means you are not fixed any of your operating parameters. You don't know what is your parameters to get your desired product. That means you have to manufacture a sulfuric acid out of the sulfur and H2O. Okay, so you are not knowing what parameters I have to fix it to get it. Okay, or an ammonia, you require hydrogen and nitrogen to produce ammonia. So literature will be giving you certain parameters, but even with the simple reaction you cannot create a product. Okay, it requires so much of knowledge. I require my instrumentation team to tell me how I can recognize my pressure is low for this diaphragm pump. Okay, so if the pressure is low, can I put it as an interlock not to operate my diaphragm pump? So it should indicate me somewhere that compressor is bad. I am unable to produce the compressor pressure. I cannot operate the diaphragm pump. I cannot deliver the sufficient flow rate. Okay, so each individually studying is called HAZOP. Okay, so FTA and ETA also some of the people have asked. FTA and ETA are the detective analysis or reactive analysis. That means after the accident is occurred, you will be finding out what are the causes, for this accident. Whereas HAZOP is a proactive study and it is done at a design phase, and it is, as sir told, it will be included of so much of the team, because to set up a big plant you require all the professionals. Okay, so if you select certain study node, then see this is a big plant and I am giving you an example. This is study node 1. Okay, first they will study about this part. Tank 1, what is the incoming, what is the means like parameters may go wrong. Okay, then the lines they have indicated node 2. This is the node 2, this is node 3, and combinedly they will combine it and identify the hazards. Okay, so as I told, selecting which part you want to study is called study node. What is your point of interest is the study node. So study node is like a specific point or an element within a process or a system that are examined and analyzed for potential hazards or deviation. Suppose in this tank, okay, my operating parameters are the temperature, the liquid temperature means liquid level. Next one, if this is an open tank, so here pressure may not come, so from the tanker it is loading. Okay, how to control overflow of this tank? So I require a level indicator. So all these things are the parameters. My level, I don't want an overflowing, so the tanker should means like indication should come out from this tank that certain level has been finished. Okay, then have to indicate the operator, so the float has reached to certain level, so no more flow. The operating parameters in my tank not to have an overflow of indicator, and this may be like if it is a vaporizing, it is producing so much of vapors. Okay, so when the liquid will produce more vapors when the temperature, so sufficient. Suppose my liquid boiling point is 100 degrees, like water. If the temperature is increasing beyond 100, my liquid will vaporize. So I'll be monitoring. So high temperature means temperature than 100 degrees. That means then what is the deviation? I'll be studying. So when you're studying all this, what is your outcome? Your outcome will be the hazards. If the temperature is above 100 degrees, it will produce vapors. So that vapors may catch fire if you have an ignition source. So you are identifying the outcome of the deviations which leads to the hazards. Okay, that is called hazard and operability study. So study node is what you are selecting. Next, intention. Intention means what is my outcome? Suppose, for example, I have to manufacture ammonia. Ammonia is NH3, nitrogen, 1 molecule, hydrogen, 3 molecules, and for this I have to give 2 molecules of nitrogen and 3 molecules of hydrogen. Okay, so that I can produce 2 molecules of ammonia. So 2 molecules of ammonia is my intention. Okay, instead of ammonia, that is NH3, if my process is giving me some NH2 amine, okay, so that is not my intention. My intention is to produce ammonia. Okay, so for that, what are my inputs? So what are all the deviations? May come deviations. Flow of hydrogen, flow of nitrogen, pressure inside the tank, temperature inside the tank. These are the designed parameters, designed operating parameters. That means 2 molecules of nitrogen has to be filled in the tank and 3 molecules of hydrogen has to be filled. Not more than that, not less than that. Okay, and temperature has to be maintained some 150 degrees and pressure has to be maintained 5 megapascals. Okay, in the same there also not more than any tolerable limit. Okay, 5 megapascals means like maybe like 5 point not 1 megapascal is maybe allowed, but not more than that, because in our processes everywhere tolerance is there, because we cannot fix it with the existing setups. Okay, so my intention is this. So if it is deviating from any of this, that may lead to a hazard. Okay, deviation means departure from the intention. That means my intention is 3 molecules of ammonia, 3NH3. Instead of it, 3NH2 was formed, means it is a deviation. Temperature has increased, it is a deviation. More than 150 it has gone, less than 150 it has come. My jacket water is not working, that is a deviation. My pressurized reaction has to be carried out. Somewhere pressure leak is happening. I am unable to maintain 5 megapascals. That is deviation. Okay. Instead of nitrogen, some pipeline has interconnected because of my new employee. Okay. Instead of nitrogen, some other chlorine gas has been introduced into the reactor. Chlorine plus hydrogen. What will form? HCl acid will form. Okay, that is totally a deviation and it will become lead into a big mishap. Mishap means accident. Okay, so the deviations we know, intention, that means intentions we know. Okay, each parameter, if it is deviating, what are all the hazards we have to find out. For deviating these parameters, what could be the causes we have to find out in HAZOP methodology. Causes means what are the factors or the conditions that lead to deviations we have to verify. We have to come out with the brainstorming sessions. So consequences, as I told, instead of nitrogen, chlorine supply was given. What could be the consequence? HCl is highly concentrated acid, more than 33%. No one has been produced yet. Okay. Instead of it, it is going beyond certain temperature. It will lead to explosion. It could be a physical explosion without fire. It's like a hazardous environment. So guide words as intentions. Our operating parameters. That means most of the operating parameters are like temperature, level, pressure. Okay. If these are deviating, so how to do? That means the words are simple words like no, less, or other than, okay, more, like that. These are the simple guide words. Add to your operating parameter, then you will get the deviation. Okay. So these are the guide words: no, less, more, part of, as well as, reverse, other than. No means negation, totally. Nitrogen was not filling. Okay, only hydrogen is filling. In a reactor, if two chemicals are there, only one is filling in the tank and other chemical is not been supplied, and the same temperature as pressure is maintained, means it will become a big hazard. That means nitrogen is not there to consume the hydrogen. Hydrogen is a highly flammable gas. If you are giving that, means like if you are bringing to a flammable limit, that's all, it will explode. Okay, in a confined reactor environment. Okay, so instead of two substances, only one was allowed. No means no nitrogen, only hydrogen was filling. Less, as I told, nitrogen 2 molecules are required. You are able nitrogen. Hydrogen only filling and another material is also filling in them. So reverse flow is happening. Other than, that means complete substitution, like as I told, instead of nitrogen, you're filling chlorine. Okay. These are the
Recording in progress.
okay, because of the vacuum created, low pressure, the flow will reverse, it will come upward. Okay, more flow, increased pumping the line, okay, defective pumps, unable to give sufficient discharge, okay, fouling in the vessels, fouling in the pipelines, orifice has been restricted because of corrosion or something, okay. So these are the different examples of the guide words. So simple examples. So these are the operating parameters: flow, temperature, pressure, level, time, composition, pH, speed, frequency, viscosity, voltage, information. Okay, mixing, addition, separation, reaction. Okay. So I told you, like, no plus flow, deviation is no flow. That means no flow of nitrogen, which than 5 megapascals, that is becoming 5.5 megapascals. Okay, high pressures always it's a like bombs. Okay, then as well as instead of nitrogen plus chlorine also coming, nitrogen, chlorine and hydrogen is coming. Okay, what are the favorable reactions that will form? Because nitrogen is an inert gas, it will stay like that. Okay, nitrogen atmosphere may form reaction under nitrogen atmosphere. So we'll see the HAZOP method. How we have to do the HAZOP so how to do HAZOP we will see now. So preparation, we have to select the team. Okay, what is your okay, the chairperson, you have to select an expertise person who has involved in conducting the HAZOPs. Okay, then HAZOP study, review and assess each process. That means you divide the process into small study notes, then identify the deviations, then identify potential consequences. Next, documentation and reporting, then follow-up and implementation. Okay, so HAZOP phase 1 is first formation of HAZOP team. So and define scope and objectives. So what could be the means like documentation part? So formation of HAZOP team. Okay, so we have to select the people, then we have to define what are all the study notes we are going to see, and objectives, what is our objectives. Okay, we have to establish some ground rules, like means like when others are discussing, we should not interrupt, we have to listen to them and those things. we have to gather relevant information that is for the documents. That means what are the documents you require for this? You require P&IDs, PFDs, process and you require the the same industry is having means failure history. Okay, all these relevant documents we have to keep with you. Okay, then deviation identification, the identifying causes and consequences. Deviation identification, as I told, you have to identify your operating parameters. Then, if it is deviating, apply all the possible guide words to it. Then, identify the deviation happening in the process. Okay, identify causes. That means to have a less flow. What could be the causes? Restriction in the pipeline. Pump is unable to deliver sufficient flow. Okay, then there may be, like as I said, cavitation is happening. Two-phase flow is happening in the pump. Okay, so if you see for a small pump, suppose you for a reactor, the reactor like the it is not sufficient. There is a corrosion in the jacket water, unable to create the proper heat transfer water through the wall inside the reaction mixture. Okay, so agitator speed is not required. Means like not up to the mark. It is not having the sufficient RPM. Okay, the temperature is unable to maintain, the pressure inside the reactor is unable to maintain. Okay, then the flow of raw material is not happening. Then how tank may itself is empty. We have not the filling of the tank. Okay, all these coming potential scenarios. Mainly, we have to means like this is a design phase. You will be conducting HAZOP study in a design phase. Before this, you will be doing the pre-design phase operations. Like in the pre-design phase also, you will be identifying the hazards. Okay, with the available process description and plot plans. Okay, those in that hazard indices you will be doing, preliminary hazard analysis you will be doing. Okay, checklist, what if analysis. So from there you will be getting some outcomes, like some of the process areas will be having highly hazardous risks. Okay, so simple utility may not have sufficient hazards to concern. Okay, those things will be ranking because risk ranking also we will be doing. They may be having very less risk and will be easily identifiable. Okay, detection is easy in that risk, so we will not concentrate much on it. We will put some detection mechanisms and we will concentrate more on highly hazardous sections, highly hazardous study notes. Okay, so consequence assessment. Consequence assessment is like, so what could be the consequence? See, in a lab, every day water is splashing on your lab coat. Is it any consequence? In the same way, if an HCl acid is splashing once in a week, which will have a higher risk? Obviously, HCl splashing. Okay, and the impact analysis. Will the water splashing will shut down my process plant, or HCl splashing will shut down my process plant? That is the impact analysis. What is my production loss? Okay, if this is leaking, I cannot run my plant with a leaking pipeline if I am concerned about safety. Okay, what is the time I have to rectify this? Because if you see why we are things is the ultimate thing is production. Okay, production means like if you lose 1 hour production time, if the loss could incur in lakhs, or some places it may go to crores also. Okay, so how fast I can come back? How fast I can come back and rectify this? When I can rectify very fastly is because when I know the situation, when I know if this happens, what is my immediate corrective action? Usually they will be doing periodical maintenance, corrective maintenance. What is my corrective action? What is my immediate remedy? How to mitigate the hazard? All this comes under impact analysis. And risk prioritization. As I told, the HCl will have a higher risk and water splashing will have a lesser risk. Okay, so low risk activities usually will be taken care by any detective mechanisms. Okay, and the means like sometimes we will separate them from the process areas. Okay, like this we will first we have to prioritize your risk, then identify what are the redundancy mechanisms and corrective actions if it is occurring in real time. Okay, physical system may be broken down into smaller parts or as necessary. Okay, that means you have to divide the system into smaller parts, then you can identify the hazards fastly. You have to apply 2 or 3 guide words for a single parameter also. Okay, guide words combination also you have to do. All these things has to be recorded properly, then only you can mitigate the hazards in a real time. See, I am telling you this is done at design phase, and as I sir told, it will be done in after the modification. Any modification is occurring means then also it will be done. Okay, so this is sample HAZOP study process. First, explain overall design, select a part, that is study node, examine and agree design intent. All the team members has to agree to the design operated parameters. Identify relevant elements. Identify whether any of the elements can be usefully subdivided into characteristics. Okay, select and the guide words, apply the guide words. Is deviation credible? That means the deviation may lead to hazards. Then immediately investigate causes. Okay, consequences, and what could be the detection mechanisms. Then have all interpretations of the guide words. Have all guide words been applied to the select means like again you have to select another parameter and apply the guide words and examine whether this guide means like the consequence analysis is sufficient or not. Based on that, remedies are sufficient or not. Apply the guide word, generate a deviation, probable causes and possible Next, we have to document the deviations, record the consequences, noting the consequences, recommend corrective actions. Why we have to do this? We are doing this exercise to prevent the accidents, to mitigate the accident. If at all it is occurring also, we have to bounce back, immediately rectify the hazard and protect our workers, environment and property. Standard 61882. Okay, we have to keep the records in line with the standard. Okay, so HAZOP means like it will be useful for regulatory compliance also. If a regulatory body is coming to your organization and asking you for whether you have conducted the HAZOP, because HAZOP is one of the hazard identification technique which include deviations in the operating parameters. The necessity for more detailed risk assessment is required or not will tell from the HAZOP. Okay. So this is the hazard documentation process. Like this is serial number. Like first one, you have to assign each entry with a unique number, because then only you can easily identify. Okay. Guide words. Insert deviation guide word. That means no, less, other than. Next, element. What the guide word pertains to. That means process. Suppose which process step. That means is the reactor. In the reactor, temperature. What is the parameter? Okay. What is the deviation? Next, what are the possible causes? Who is the culprit for this deviation? What is the consequence of this deviation? Next, what are the safeguards you want to keep to prevent this deviation? Then relevant data, actions, any actions required, we have to record it. Okay, this is the little examples of the HAZOP methodology for the cleaning agent. No cleaning agent. Okay, no detergent added during the cleaning cycle. Detergent this is empty, no cleaning agent was added. Okay, residues not effectively removed. That is the consequence. The outcome. Okay, the safeguards. Technicians check detergent reservoir before every cycle. This could be included in the safe operating procedure, so that before the cleaning job you take up, okay, technicians has to go and check for the reservoir. Okay, assumes technicians can reliably estimate volume visually. That means here with visual inspection. Consider alarm for low detergent reservoir level is the future action. With this means how you can get this level through level indicator. That means through float you can control the overflow also, and level indicator will give you the level indication in the tank. So whose job is this? It is engineer's job, process engineer's job. Okay, HAZOP action. Whatever the action we have just seen, that has to be recorded. So documents for HAZOP review, updated process and instrumentation diagrams, operating instructions, a plot plan with the location of various equipment items. Plot plan will tell you what are all the additional consequences, like where the pipe is bending. Is it coming from underground? Is it going above the reactor, below the reactor? Okay, all these things matters because this may lead to some obstructions also. Okay, process flow diagrams, interlock description. That means in the previous one, if a tank is having an interlock that below 30% of level, cleaning operation or cleaning machine will not start. Okay, that is an interlock. Set points for all the interlock sensors. Visual capacity, design pressure. That means visual capacity means I have to fill the 1 meter cube volume in 500, literally half. Okay, so capacity is a must. And design pressure, when you are designing a vessel, okay, the thickness of vessel is taken care based upon the working pressure inside the tank. Okay, so if I want to have an atmospheric pressure for my vessel, I can take only the load pressure alone I can take. But if I am operating the same tank with a higher pressure, my thickness will increase from 40 schedule to 80 schedule, 100 schedule, like that. Okay, also we have to see. So benefits of HAZOP is enhanced safety. Okay, because potential hazards are identified through this, which will protect employees and the surroundings also. Risk management, this is a proactive approach. Okay, we can assess the risks and mitigate the risks also. Compliance with the regulation, it is mandatory in some countries. Like before you go for the license for operating your process plant, you have to do this. You have to submit to the respective staff. Operational reliability, you can verify. That means you before itself you can define this pump will work for 10 years. After 10 years I have to replace this pump. Okay, you can before itself means like after 10 years if this is giving you a malfunction, then means like periodically if you are changing it will be better. Okay, so with this HAZOP you can get the useful time of the equipments also. Financial saving, because accident will have so many indirect costs. Okay, indirect financial things which will not be visible. Okay, sometimes, so you can save a lot of money. Limitations, like what is the limitations of HAZOP? Means like if I am unable to define my intentions, I will do my HAZOP study in a wrong direction only. Okay, so complexity for large systems. If I am doing for a petrol industry, it will be a very much complex system. So carefully you have to do. And the HAZOP team should be, selection of HAZOP team should carefully taken. Otherwise, it will lead to it a different way. Subjectivity. And main thing, HAZOP is an qualitative analysis. It is not a quantitative analysis where you will not deal with any numbers. Okay, subjectivity. If Nancy is feeling this means no flow will lead to the accident. This is my opinion. So her is feeling no, this may not lead to so this is having that limitation. We cannot define it in numbers. Okay, how much hazard it will lead, how much hazard it lead to, that will be subjective nature, not in a quantitative manner. Okay, not sufficient, we have to do other hazard identification techniques also. So example, so I know everybody knows about Bhopal gas tragedy. People will tell this is the this is having, like, if you see this, how many safeguards are there, flare cover, vent gas rubber, water curtain, refrigeration system. Okay, in visual you have 4 safeguards. All the 4 safeguards were not worked when the MIG gas is leaking. Okay, so if at all you think, if at all HAZOP is done for this plant, you could have saved thousands of lives.
Sorry for the trouble. I think there is a small video feed issue from Nancy's side. Hope she comes back. But still, I will continue with this thing. As all of you know, what has happened in Bhopal gas tragedy, there was a complete, a complete misconcept of the entire engineering techniques itself, where they haven't identified what could go wrong. Yes, she's back. Over to you, Nancy.
Okay, so if you would have done the HAZOP study at the 1984, that means if at all the pipeline disconnected to vent scrubber in the case of the MIG gas releasing, okay, they would have analyzed the consequence. Okay, water curtain, what height it is reaching, it means like whether the sufficient flow is not there for the water curtain. Okay, what could be my consequence? For safeguards itself, if they would have done the HAZOP, they could have saved thousands of people's life in the Bhopal. Okay, so water enters the MIG tank. Okay, then see, actually in this what happened, briefly I will tell you. Nitrogen blanketing was failed. Water entered into the MIG, this tank, and runaway reaction has happened. If this is also they would have analyzed. If water is entering, okay, nitrogen blanketing is failing, what could be my consequence? Okay, so runaway reaction has happened. It pressurized the system. It was leaked out of the system because of the old system also. Okay, that means the pipelines were having leakages. All these things were there. It just not happened just in that night. Okay, so what they have done, if this runaway reaction is happening, they know that they have to cool the system to control the reaction. For that only they have kept the refrigerant system, freon, but this freon was sent to another plant. Okay, so there is no refrigeration system working here. So there is a vent scrubber where it will scrub the MIG gas so that the toxicity will reduce if at all it is going out. Okay, so water curtain also same, it will reduce the toxicity. Flare cover, it will burn the MIG gas, it will convert it into carbon dioxide and other things. Maintenance. This is the P&ID diagram for the storage tank. Total means like scooter kind of thing, like a danger siren. Okay, then also some people would have been rescued. Okay, and the means like safety valve. If it is connected to the stubber circulation pump, each and every node, if you are studying, okay, this will give you so many consequences. Okay, we'll see a simple example. So material A and material B has to load into the reactor. Okay, for that pump A and pump B is there. For example, if I am selecting this pump A, when the pump A will not work, is not there in the reactor, when it will happen? Material A, no flow of material A, no flow of material A will happen, may lead to explosion, for example. Okay, then what are the causes for this? There is no material A in the tank, there is no sufficient discharge from pump A, valve is closed, line is ruptured. Okay, these are the possible causes, okay, for no flow. Okay, that we will see. So we will be identifying the diagram and who are all the team involved. Also we will be noting down. Okay, transfer line from supply A to reactor. Okay, so source is tank for A, destination is the reactor, activity is transferring. So no material A, no material A is the deviation. So possible causes, supply tank A is empty. Consequence, no flow of A into the reactor, it will lead to explosion. Existing control, nothing is there. So situation is not acceptable. Okay, and required actions, if there is a low alarm, flip the pump. More material A. Okay, more material A, supply tank. Tank will over bounded area. Existing control, there is nothing. This would have been identified during the examination of the tank, or we can put a float to control the overflow. Less material, that is subjective, is not telling you about the quantity, exact quantity. So no level in the tank. Inadequate net positive section head. This net positive section head means there is no inadequate suction head to discharge. That means this is mostly occur in pumps drawing from a underground reservoirs. Okay, reverse transfer A, reverse direction of the flow. So I can apply 10 guide words for the same material A to see how it deviates from transferring. Okay, these are the references. These are the following documents required. That means references for this HAZOP.
Sorry, I think there is a
well recommended.
Yeah, or audio break over there. Yeah, I think there's it's all done. So these are the references that have been used, and thank you, Nancy.
Yeah,
for,
okay.
Thank you, Nancy, for giving a wonderful session on the HAZOP exam.
Yes, sir. Thank you, sir. Thank you.
Yeah, small study on it. So what I'm going to do is that we will have, if you could kindly stop the screen share, Nancy, then I can share my screen, which is for the last one where we have to discuss. Thank you for all attending. It's a wonderful session on the HAZOP study that we that is screen is sharing as we speak. So for all of your attendance, the certificate would be sent to your registered email ID, and you can always reach us through our website. Our contact details are there on our website, but screen sharing is paused. I don't know why. It should have been sharing a screen, and yeah, there it is. There. So this is our contact details. You can always reach us. This is our WhatsApp number. If you kindly note our WhatsApp number, you can send a message on it, and we will be happy to do any help for you. And there is the same thing that we have studied. We have actually certified it through CPD UK, Continual Professional Development Accreditation Body from UK. We have a course for that. You can get in touch with us in any of this email ID or through this WhatsApp. They can give you a detailed information about the course that we do have on HAZOP. So finally, on a side note, really appreciate each and every one of you to attend this 2-hour long session of webinar. Your CPD certificate should be getting across to your registered email ID once I close this webinar. Once I click the end webinar session, you will automatically receive your CPD certificate. Save these CPD certificates on a folder. As an aspiring learner, as a professional, you should attend not only our webinars, there are different webinars available and usually conducted by NIBOSH, IOSH, and many other accreditation bodies and all. Attend all these webinars, get the certificates over there, and if any of you are having IOSH memberships, IIRSM memberships and all, you need to do your continual professional development through their website, and all these certificates will help you to get the 3 points that are required. For example, IOSH annual audit would require you to complete 30 CPD points. Our certificate is worth 3 points. That means one of our webinar will get you 3 points. So every month we have one webinar. If you attend 10 of our webinars, you will easily get your 30 points, which will help you to maintain your IOSH membership status. Please note that IOSH is very strict now. They are closely monitoring every member's CPD progress, CPD processes, and you have to enter evidences on how you maintain your continual professional development. So this particular webinar will help you to gain that. And this is our contact details. You can always get in touch with us, and I have tried my level best to answer all the questions, almost to everything. And if there is anything at all, any kind of doubts or anything, now last minute somebody is asking of LOPA and all. Seriously, this is already the time has completely finished. Get in touch on this WhatsApp. My name is Shankar, and you can reach me. Get in touch. You need to speak to me. They will be happy to give you my contact numbers and all, and we will be more than happy to see you throughout our future journeys. Really appreciate and thank you for keeping your confidence with the Greenberg Group, and we will be more than happy to assist you throughout your learning journey. And as this is our 18 years, and all the best and good night to all of you. Thank you. Bye-bye. All your certificates will come to your registered email ID. If anybody faces any trouble, get in touch with us on this WhatsApp and we'll be happy to look into it. Thank you all. Safe journey if anybody is traveling. Otherwise, a good night to all of you. Thank you all. Thank you.
Thank you all. Good night.